Welcome back, dear students. In the last session, we solved a few questions of exercise 6.5, that is question number 8, 9 and 10. In today's session, we'll continue with the exercise. We'll solve few more questions, that is question number 11, 12 and 13. Let's continue with question number 11 first. Okay, in question number 11, it's given that there are two aeroplanes. One is flying due north, another is flying due west with the speed of 1000 km per hour and 1200 km per hour. So there are two aeroplanes, one is flying due north, another is flying due west. With this aeroplane is traveling with 1000 km per hour and this is traveling with 1200 km per hour speed. Okay, so we need to find the, and they flew for 1.5 hours. Okay, they flew for 1.5 hours. So we need to find the distance between the aeroplanes after 1.5 hours. Okay, so practically it's not possible. Okay, it's very difficult, but by using mathematics we can find the distance between the aeroplanes after 1.5 hours. Okay, so let's write the steps. Let's write what's given. First is speed of north flying aeroplane is 1000 km per hour. Okay, and west flying aeroplane is 1200 km per hour. So distance between the two planes after one and a half hour. Okay, after 1.5 hour, that is 1.5 hours, is BC. Okay, first aeroplane flew, this A is airport. They are taking off from A and this aeroplane is going towards B and this aeroplane is going towards C. So we need to find the distance between the aeroplanes after 1.5 hour. Okay, so that is BC we have to find here. So practically it is not possible because they are very far from each other. They are flying very fast with 1000 km per hour and 1200 km per hour speeds. Okay, so let's see how we can use Pythagoras theorem to solve this complicated question. We know that speed is equals to distance by time. You might have learned this in science also. So we'll apply distance is equals to speed into time. Okay, I can write distance is equals to speed into time. So here this is the speed of the aeroplane. This is not the distance. Okay, that is the speed. So up to apply Pythagoras theorem, I need the distance traveled by the aeroplane towards north and towards west. Okay, I need the distance here. Then I can find this distance very easily by using Pythagoras. So let's see how we can find the distance traveled by both the aeroplanes. So distance is equals to speed into time. Now I'll make a table. Okay, so speed of north flying aeroplane is 1000 km per hour and that is traveling for 1.5 hours. Okay, and west flying aeroplane speed is 1200 km per hour and it is also flying for 1.5 hours. So we will multiply now. To find the distance, I'll multiply speed into time. Okay, speed and time I'll multiply. So here I get 1500 km. Okay, if you multiply 1.5 is nothing but 3 by 2. Okay, that mixed fraction you can convert into proper improper fraction. So that becomes 1.5 becomes 1 2 is 2 plus 1. Okay, so that is 3 by 2. So when you multiply 1000 with 3 by 2 you get 1500, and when you multiply 1200 with 3 by 2, or that is 1.5, you get 1800 km. Okay, for your convenience let's simplify it. So you can see 1.5 I multiplied with 3 by 2, sorry, 1.5 is nothing but 3 by 2, multiplying 1000 with 3 by 2 500 times, then 500 into 3 is 1500 km. Next, AC 1200 into 3 by 2, so 600 times I can cancel it, then 600 into 3 is 1800. So it's simplified for your ease. Now we have to find distance BC. Okay, we can easily find this distance BC, because this is perpendicular. Okay, AB is perpendicular to AC, so this is a right angle triangle. I can apply Pythagoras theorem here. Okay, that is hypotenuse square is equals to height square plus base square. Let's substitute the values in the form in this step now. BC square is equals to, this is hypotenuse, BC square is equals to AB square plus AC square. We know AB and AC values. We'll substitute the value of AB, that is 1500 kilometer, and AC is 1800 kilometer. When you square them, okay, square them and add them, you get 54,90,000 54,90,000 under root. So when you can't leave it in roots, distance cannot be in roots, so we'll simplify those that root value. Okay, we can, hope you remember in Heron's formula I showed you the method of finding root easily. So you can find the prime factors of 54,90,000 and split them in this way to get 300 root 61 kilometers. Okay, 300 root 61 kilometer. This is the distance between the two aeroplanes after 1.5 hours. 300 root 61 is also very large value. Okay, so this is the end of the problem. Next, again we have an application question. In this case, two poles of height 6 meter and 11 meter stands on a plain ground. So it's given that there are two poles. One pole is AB of height 6 meter, another pole is CD of height 11 meter. They stand on the plain ground. This is the ground here. AC is the ground. If the distance between the feet of the poles, this distance between the feet of the poles is how much? 12 meter. This is a simple trigonometry question, I can say. Okay, you'll find this type of questions in trigonometry also. Okay, with the name heights and distances or application of trigonometry. Okay, so we are using basics of trigonometry here. So distance between the feet of the poles is 12 meter. The pole, these are the poles and these are the feet. Distance between the feet is 12 meter. What we need to find here, we need to find the distance between the tops. So which is the top of the pole? These are the tops of the poles. So we need to find what is the distance between the tops. So for that you don't have to climb the top of the pole to measure the distance, just you have to use the knowledge of Pythagoras theorem here also. So let's write what's given. Height of the first pole AB is 6 meters, okay, and height of the second pole CD is 11 meters, and distance between the feet of the poles is 12. We have to find the distance between the tops of the poles. Solution. So we'll draw a line BE perpendicular to CD. This is not given, so BE will also be equals to 12. Okay, because these two poles are parallel to each other and they are on the same base. So whatever is the length of AC, same will be BE also. So BE is equals to AC is equals to 12 and AB is equals to EC is equals to 6. Okay, I can easily find the distance between the top of the poles. This distance I can easily find if I know this height. Okay, that is ED. So this total length is 11. From 11, if I remove the 6, I get 5. Okay, so DE is equals to 5 meters. So I'll take this triangle alone now, this triangle BED, because I need to find the distance between the top of the poles. So I'll take this triangle BED and I can apply Pythagoras theorem there. Okay, so since BED is right 90 degrees, right angle triangle, we can use Pythagoras theorem. BD square is equals to DE square plus BE square. So we need to find BD here. DE is already given, that is 5 meters. Okay, this is 5 meters and this is 6 meters, so total will be 11. Okay, So 5 square plus 12 square, that is 25 plus 144, and that gives you 169. So root of 169, when I remove the square from here, I get a root. You know that very well. So BD is equals to root 169, and that is 13. So distance between the tops of the pole is equals to 13 meter. So this is all about the application questions of triangles. Now let's see the last 13th question.